Welcome to part 1 of evaluating the given triple integral over the region E, where E is the solid bounded by the parabolic cylinder z equals x squared and the planes y equals 0 and z equals 11 minus 4y. In this part, we'll set up the triple integral by determining an order of integration and the corresponding limits of integration. In part 2, we'll evaluate the triple integral. Let's first look at the solid region E in space. The region of integration is the region bounded by the cylinder z equals x squared graphed here in green, and the plane z equals 11 minus 4y graphed here in gray, as well as the plane y equals 0 graphed here in yellow. So notice how the bounded region, or the solid region, is going to be this region here, where it's bounded below by the cylinder z equals x squared, and above by the plane z equals 11 minus 4y. And notice if we look down on the xy plane, it's a little hard to see, but the xy trace would be this area here, bounded by this parabola and this line here. So going back to our work, we need to select an order of integration. Let's let dv be equal to dz dy dx. So we'll have the triple integral, where the integrand function is just y, and then for differential v, we'll use dz dy dx. And we saw from the three-dimensional graph that the region E is bounded below by the cylinder z equals x squared and above by the plane z equals 11 minus 4y, which means with respect to z, the lower limit of integration is going to be x squared and the upper limit of integration is going to be 11 minus 4y. Now you might be asking, how would you determine which of these is the upper and lower limit if we weren't able to look at the graph in 3 dimensions? If this was the case, we'd actually have to pick a point in the xy plane to see which surface is below and see which surface is above. What I mean by that is if we have z equals x squared, we evaluate z at the ordered pair 0, 0, where both x and y are 0. Notice how z would be equal to 0, but for z equals 11 minus 4y, if we evaluate z at 0, 0, we would have 11 minus 4 times 0, which gives us 11. So notice how this shows us that z equals x squared is below z equals 11 minus 4y, which again is another reason why the lower limit of integration for z is x squared, and the upper limit of integration for z is 11 minus 4y. Now from here, to determine the limits of integration for y and x, we want to determine the xy trace, which is shown here. Let's explain where this came from. Using the given equations, we have y equals 0, which is the graph of this horizontal line here. And then we have the equations z equals x squared, as well as z equals 11 minus 4y. Well, we need an equation in terms of only x and y to complete the xy trace. Since z equals x squared, we can substitute x squared for z in the second equation, which gives us one equation with just x and y. This would give us the equation x squared equals 11 minus 4y. And if we solve this equation for y, let's go ahead and add 4y to both sides, as well as subtract x squared on both sides, which would give us 4y equals 11 minus x squared. Dividing both sides by 4, notice how we get y equals 11 fourths minus x squared divided by 4. So this is a graph of this parabola here, where this y-intercept would be 11 fourths. And we also need to find the x-intercepts here, and we find the x-intercepts by setting y equal to 0. So if we know that x squared equals 11 minus 4y, if we set y equal to 0, we'd have the equation x squared equals 11, so x equals plus or minus the square root of 11, which gives us, again, the x-intercepts for the xy trace. And now we can use this area here from the xy trace to help us determine the limits of integration for y and x. Notice how this area is bounded below by y equals 0 and above by 11/4 minus x squared divided by 4, which give us the limits of integration with respect to y. The lower limit of integration is going to be 0. The upper limit of integration is going to be 11/4 minus x squared divided by 4. And then for x, notice how the leftmost point is here where x equals negative square root of 11, and the rightmost point is here where we have x equals positive square root of 11, which means the limits of integration for x are going to be from negative square root of 11 to positive square root of 11. So this completes the setup of our triple integral over the region E. So we'll stop here for part 1. In part 2, we'll evaluate this triple integral.